So here is another type of real-world situation that we can use the Pythagorean theorem for. The transmitter for John's thermometer has to be less than 50 feet from the receiver. It's not going to pick up if it's more than 50 feet away. So he places the transmitter here, and then the receiver is here. And we need to determine if these components are actually less than 50 feet away from each other. Okay, so take a look at the shape and think about the concept that we're working on now is Pythagorean theorem. How can we use that theorem with this image to figure out the distance? Okay, so this, hopefully you saw, if you're looking at the rectangle, you could have drawn a right triangle. Okay, what makes a triangle a right triangle?
If the angle is 90 degrees.
We need one 90-degree angle. And what does a 90-degree angle look like?
It's like an L.
Yeah, like an L, like that perfect L. So here represents our 90-degree angle. So I know that that's a right angle because it makes a perfect 90 degrees. Now, we already have labeled the sides that we know. We know this is 32 feet, and we know this is 24 feet. Do we have enough information to figure out the distance between the receiver and the transmitter?
Yes.
Yeah, why do we have enough information? When we use the Pythagorean theorem, what must we have? Do we have to have the two legs? Two what?
Sides.
We need to have two of the three sides. It doesn't matter if they're both the legs. What do we have here? Yeah, we have the two legs of the triangle. So we can use this to represent that situation. What values could you actually replace in the Pythagorean theorem? We can replace A and B. Okay, so A is 32. B is 24. And then we're going to find that length. Now, how do we know that this represents? Why are we able to use this theorem in this example? There's one really important part of the image that proves we can use the Pythagorean theorem. When can we use the Pythagorean theorem? Any triangle? Any right triangle. And that's key because you're not always going to be given a right triangle. You might be given a different shape. But here we can create the right triangle. Okay, so now I want you to calculate this. If we know that one of the sides is 24 and one of the sides is 32, you all have calculators. Your notebooks should have been open since the beginning of the lesson. Could you figure out what the distance would be between the transmitter and the receiver?
It's 40.
Who wants to tell me what you got when you squared 24, Mercedes?
576.
500. Who wants to tell me what you got when you squared 32? Michael. 1,020. 24. Right, if I add that together, what do I get? What is the last thing I have to do? I have to find the square root. Frankie, when you find the square root of 1,600, what do you get? What is it?
40.
40. So if the distance here is 40, is that transmitter going to work? Yes, it will. Why? Because it has to be less than 50, exactly. So taking it to that next level up, when you're dealing with a real world type of Pythagorean theorem problem, the answer isn't always going to ask you just for the side length. This one was specifically asking if the transmitter would work with the receiver. By finding the distance, you were able to answer that it would work. We already answered this. What is it about a rectangle that allows us to use the Pythagorean theorem?
If
like this.
No.
When you cut a diagonal,
If I cut a rectangle diagonally, I have two right triangles. Now, do I have to cut it in half? Could I create a right triangle anywhere in that rectangle? Yeah, what else could I do? I can cut it anywhere. For example,
as long as you cut diagonal.
did I just make a right triangle? Yeah, even though it's not half of the rectangle, this is a right triangle. What is it about the rectangle that's really helpful when it comes to creating right triangles? Yeah, a rectangle has 4 90-degree angles. There's one here, one here, one here, and one here. So any combination here, even this one, that one, those are all little right triangles that you can make if you had to. Now this comes into play because sometimes you're not going to be given a triangle. Something like this might happen. How would you find the area of this shape? I want you to take 5 minutes. And I want you to find the area of that shape. Now you're given it's almost like a coordinate plane, right? Each one of these would be like a unit. So I want you to figure out how you would find the area of that shape. And I'm saying that shape because some of you may see it as a rectangle, some of you may think it's a square. We cannot necessarily confirm yet if it is a square or not, but what would you do to find the area? I'm going to start the timer. I'm actually going to pause the recording because the real-world application of the Pythagorean Theorem. Actually, no, I'm going to leave it because when we go over this, it'll be helpful to have this recorded. Think about what you would do. What you would do. Say again? We're trying to find the area of that shape. You could, yeah. Well, if it's distance, then it would have to be this way.
I just told you. See how it's like.
Who has an idea? What could we do? What could we do to find the area? Some of you are trying to work through, some of you are kind of staring off into space. So let's try to focus here. What are some options? We have a shape. It's on, almost looks like a pegboard, but we have some way of finding our distance, right? We do have those points that almost look like a coordinate plane without the lines. Michael, what's an option?
Tilt the paper.
You could tilt the paper. But if it's on the computer, can I really tilt the, is that going to help me?
That's what I'm gonna answer.
Is that going to help?
A little bit.
How?
Count spaces.
Can I? Do I know what this is? Or this? Now we want the exact area. Can we, just by tilting the paper, can we find it? How do we find the area of a shape like that? So, okay, you're saying length times width. You're correct. That's what we would need. How do we find the length and the width?
Use the dots.
How?
What? That side's 4 because at the top. Move the line over.
Is it though? Yeah.
2, 3, 4.
But if I took this and moved it up and rotated it, is it really 4?
Yeah.
Because that was 4 units, but now it doesn't look like it's 4 units.
In the middle of the paper, there's like in the middle of the square, there's like 4 units that go directly across.
Here?
No. Right there.
Okay. How does that help?
Because then you can take that one.
And do both.
Because that's well,
Rotate
it should be
the
longer than that.
Yeah.
Oh, it's so small.
Now, we already had mentioned, and you're correct in saying, that in order to find the area of that shape, we would need to know the length and the width. We need to somehow know this length and this one.
This is where it goes, but we can't explain.
How can I find them? Think about what we've been doing. What did we do earlier? It's all connected.
Cut it off.
How?
Oh, can't you just take that line?
What do you mean cut it in half? Think outside the box here. Be creative with how we can find these two values.
Can't you just like draw the line,
Okay.
take the line, and then rotate it so it's straight, and then line it up, and just make a whole new box? You take
How
the
would that
side-
give us the exact
Because you
measurement? I mean, we already showed that it's going to be, it looked like it was more than 4, but I didn't know exactly how much more. We want to calculate the exact area. Exact area, we would need to know that length and that width. There is a way we can find them. Think about how we find a side length. How have we been finding side lengths for the last week in class?
oh, wait, are you talking about the way we did the thing before?
It's all connected.
She wants us to do that.
What have we been doing? Think about the unit that we're in. It is all related.
Make it into a triangle.
How?
With the
Cut.
right angle.
Where?
On the
In the
angle.
middle.
Just in the middle?
No, angle.
Who can create one? Now remember,
Christian wants to go.
if I need to find this side length, how could I create, like Frankie had said, create a triangle? How could I create not only a triangle, what kind of triangle?
Right.
A right triangle. How can I create a right triangle that has this as part of it?
Put a square in the bottom. And go.
Where? Where can I put it? Kind of. You're on the right track. I'm going to erase this one.
Let it diagonal.
If I need to find that red line,
Yes.
do I know any other values? Can I be creative and find a way to use the Pythagorean Theorem to find that red line?
Both on like a or non-integrating.
Are they?
Yeah.
If I need to find that side length, what do I need in order to use the Pythagorean Theorem?
Two other sides.
I need to know the length of the other two sides. So if you're going to create a triangle with that red line being part of it, you need to know exactly the other two sides. Can you use the picture to find it?
Yeah.
Measure all the sides of that
Can you
red
explain
line.
more?
But you said to draw a triangle. You said create a triangle. What triangle could I create?
Like so, you can take it from the top one.
What top corner?
All the way
Up here?
you have to go up to the bottom.
Did I just create a right angle?
Yes.
No, not there. To the other point.
He
Oh,
moved
but you gotta
halfway.
use the dots. Oh, we have to use.
We're going to have to, because in order already told me to use the Pythagorean theorem, you need to have the other two sides. If that one is unknown, then the other two sides of the triangle need to be known.
And if you go down, like how you did it,
Right.
that's 5.
It is, but I would need to know two of the sides.
And then
And also, by creating this line, is it helping me find the red?
yeah.
How?
Yeah, how?
Just
It's
cut.
not.
Do it. Do it like.
No. Think about this. You don't have to. We just talked on the previous slide. You don't have to just cut it in half. How can I create a right triangle from this image that is going to give me that red line?
Follow that line.
Which one?
The one. The little.
Which one? Tell me where to go.
The third. The second one.
Here.
Yeah. And then
This?
you touch it with the other one and you go to the side.
What do you mean?
They just go to the mother, same thing, but just different.
Yeah, like you rotated it.
Yeah, they just rotated it.
What am I? How?
Keep going.
Yeah, she wants you to go all the way, but that's the same
That?
thing, just rotated.
That's the same
Do I
thing.
know two of the sides?
Yes. No.
No, I don't know two of the sides.
It's 2 and 5. 1, 2, 3, 4. Yeah.
This is not two.
No.
So while this might be 5, I don't know this, so that's a problem. But am I all wrong here?
No.
What else could I do? Remember, I need to know two of the sides. You have a way to know this side. What else could I do?
Wait, oh, I know what to do.
What?
So you go from that point that the black line started, go 4 dots in, and then go straight down. And then you go to the side.
Did I create a right triangle?
Yes,
Do I know two of the sides?
yes.
Yes. What is this side?
4,
4. What is this side?
2.
2. Find the other side.
It's 4 times 4
Oh, 4.5.
4.
How did you get what was it?
It was
4.25.
4.472, so that would round up to 4.5.
Okay. Let's see. What did you do to get that?
I got something different.
We're gonna go through what we did. What did you do to get that?
4 squared.
4 squared, which is 16, plus
2 squared.
2 squared, which is
4.
4, equals 20, and then what?
Squared.
Square root of 20. What's the square root of 20?
4.4.
Oh, I added wrong.
4.47. We can say 4.5. We have one of the sides. Can we assume that this is a square? Should we assume that this is a square?
What?
Should we assume that this is a square and that the other side is 4.5? We should just assume and move on?
No, you gotta find
Now,
the
how
other
can
side.
we check? How can we get this side? Again, if we're going to use the Pythagorean theorem, how many of the sides do we need?
2.
You need 2 of them. So how can I create a right triangle with 2 known sides
Do it
to
same
get
thing.
this value?
You
How?
go down 4 and you go down 2.
Is that a right triangle? Yes. Do I know 2 of the sides?
Yes.
Yeah, this one is a 4 and this one is a 2, which means what would this be?
4.5.
So what's the area of the whole thing? The whole box. How do I find the area of the whole box? Length times width, which would be
224.
4.5 times 4.5 should be
20.25.
20.20. So what did he do? This is a way to use the Pythagorean theorem when you're not given a triangle to begin with. That concept of using 2 sides of a right triangle to find a third side works in so many different situations, even when you're not given a triangle. And I want you to try this one on your own. Okay. And now that you know what you're going to do, it probably won't take you as long. Let's take about 4
Is
minutes.
it different or not?
It's a different size, same concept.
Oh,
Okay. So take about 4 minutes. How are you going to find the area of that shape? I'm going to pause the recording now as you guys work through this problem.
You're gonna line up.